Once you have determined what dependent and independent variables you will use to test your hypothesis, you're ready to design an experiment. Scientists design experiments to test whether the independent variable actually affects the dependent variable or not. Specifically, they have to manipulate or change the independent variable and then observe whether that change has any effect on the dependent variable. So in our example, we might water the lawn different amounts and then observe that the lawn grows different lengths depending on how much water it was given. To accurately measure the effect of the independent variable, or the water, scientists need to set up two groups of experiments, one in which the independent variable is present and the other in which it is absent or altered. In our example, you could picture dividing the lawn in half, like in the picture, and watering only one half, and then comparing the growth of the grass on that half to the growth of the grass on the other. So we'd be comparing the effect of watering and not watering, or comparing how the presence and absence of the independent variable affects the dependent variable. In this case, the grass blades on the unwatered half of the lawn would be called the control group, and those from the watered half of the lawn would be the experimental group. Most people think to create an experimental group, but they sometimes forget to create a control group to compare to. And in science, having a control group is essential, because how can you really show that your experimental group grass grew a lot more because of watering? You can't show it unless you can compare it with a control group that didn't get water and say, look, it growed more than that group. So make sure when you design your own experiments that you always include a control group in addition to an experimental group. And once you've done that, you're ready for the crucial final piece of an experiment, the prediction. So the prediction is a restatement of your hypothesis that you had designed earlier. But now that you've designed your experiment, you need to reiterate your hypothesis in a more specific way. So, before we might have said a general hypothesis like watering grass causes it to grow longer. Now we can say, on this lawn in my yard, the half that receives this much water is going to grow this much more than in the half that does not receive water. That's a prediction that's specific to this experiment, so it's an adaptation of your hypothesis to make it more relevant to what's right in front of you.